Okay, welcome to our fireside chat with Anantha Kancherla. Anantha is the VP of ADAS at General Motors. Welcome, Anantha.
Thank you. Excited to be here. We are big users of Applied, so.
Anantha, before you joined GM 9 months ago, you had a long career in engineering and AI. From 2017 to 2021, you headed Lyft's Autonomy division as their VP of engineering and software. Today, we're going to talk a little bit about your background in autonomy, your focus on ADAS and AI at GM, and GM software more broadly. So to start, we'll talk about AI. I noticed that you have an AI sweatshirt on. It's a lot of the talk of the town today. You've worked on AI technologies for applications across a variety of different industries, across automotive, healthcare, and beyond. What do you see as the game-changing AI technology for automotive?
Actually, all of it. I don't think that there is anything specific that is happening in the AI world that is unique to automotive. But at the same time, what I will say is that everything that is, all the breakthroughs that are happening in AI are applicable in the automotive world as well. And it was basically true in the beginning, like when the first convolutional networks happened. That's kind of what gave rise to this entire autonomous driving boom, to the transformers breakthrough that happened in 2017, foundation models, like all of it. So I don't think that there is anything exclusive I can say, oh, there's stuff that is happening that I can say it's kind of useless. No, it's just a very, very exciting time for automotive as well.
As a leader in the AI group at General Motors, how do you stay up to date with what the latest technology is? How do you think about what is the right amount of cutting edge technology to bring into production systems? How do you kind of think about that?
Yeah, actually, this is, I'm actually a relative newcomer to AI. Like, I haven't done my PhD in AI, and my background is all 3D graphics. And so my entry into AI was eased by the fact that I worked on the early GPUs. I used to work with all the GPU companies. We spec'd out like what the architectures are. So a lot of it is like, linear algebra. So when I saw what was going on with like deep learning, it kind of felt very natural to understand what's going on. Conceptually and mathematically, it's like not that complicated to get started, but really where it gets like tricky is learning the tricks of the trade, the intuition, the whole focus on data. Like there's a bunch of things that come with it. And so truly my journey in that whole area began like when I worked at Lyft. And in the early days, I would basically ask my team to send me papers that they thought were interesting things that are going to be worth my time. And every time I would make these long flights, I would just read them. And I have kept that habit. So the best way to keep up with AI is reading papers. And in between, I worked as a full-time engineer at Meta, so that gave me an opportunity to get my hands dirty and work on things. So it's just like you kind of have to be involved in it, and you will keep up.
On the note of data, it's interesting with the advent of technology like ChatGPT, large amounts of data are being used to create these really advanced systems. Mm-hmm. A lot of people are seeing machine learning problems as just data problems and data collection problems and collective annotated data. On a podcast in 2020, you had mentioned finding the right type of data is more important than just having a lot of it. Right. Is that still true today? How do you think about that?
Yeah, absolutely. I think it's absolutely true today. What LLMs, the breakthrough of ChatGPT has shown is a couple of things, right? Like number one, it's shown that the scaling laws. It's really, I would say, less of an invention, more of a discovery. So we discovered those scaling laws. So we said more data you throw at it, better it gets. But it is still important to figure out what data you throw at it. And this is the reason why there's so much effort that goes on in the post-training world as well. And that continues to be true. So you kind of have to figure out how to identify the right set of data to throw at it. And more you throw at it, better it gets. And what is really interesting is the sudden realization that the world we live in is amazingly complex. And it's kind of like fractals. Every little detail you go into, there's more detail to figure out. And that's kind of what this helps.
In terms of data and things like safety and traceability, at GTC this year, a lot of AV companies have outlined new approaches for ML-based approaches, new ML-based approaches. How do you think about this kind of area of black box system versus traceability and safety? How do you kind of think about that?
Yeah, so I think the trick with working with ML-based systems, there's a couple of things. Like I think one very important thing we just spoke about is data. So having the ability, like your AI system is only going to be as good as like your data is. Of course, like there's a bunch more things required. You need to have like the right compute infrastructure and all that, but like that plays a critical role. So being able to like have a good understanding about the distribution of your data set is really important. So that means like you need to have the ability to characterize what the world of which you're capturing the data. So having that characterization, you need to quantify it to turn it into something that a neural network can understand. So I think what that really means is like having really effective metrics or measurements for the model. That said, you still need to have your end-to-end system, end-to-end metrics figured out, whether it is like, the number of disengagements or the, like how many minimum risk maneuvers that you're going to do. So all of that is like going to be really important. There's a few things that are happening in the world of AI, so back when I was at Meta, it was something that like we focused on quite a bit, which is like understand the explainability of AI. I think there's a lot of things which are still in the research domain, and I'm really looking forward to seeing like more of that coming out and make it usable for not just automotive, but like the broader AI world.
In terms of AI in the automotive world, right now, competition for software talent and AI talent is extremely competitive. How did you choose to join GM? How do you kind of think about making GM or the automotive market an attractive place for top software talent?
So the talent for top talent, the competition for top talent has always been intense. Like it's never gone away. It's just that like where the focus has been. So in the past, like when iPhones just came out, like we used to like run after like the few mobile engineers, and now we are running after like the few.
There's always the trend in technology where the smartest engineers go.
Exactly, because the next big breakthrough it's basically supply and demand, right? Like there's a very few of those people who know how to do these complex AI. And so yes, so that's always going to be there, and we just need to like figure out our hiring strategy and value proposition to the people who are working on it. For me, it kind of felt like a great place to be, and one of the reasons why I took on this role is it checked a lot of boxes for me in the sense that like, number one, is this company innovative? Like, is this what like we want? Are they like willing to take some interesting bets? And what I realized was like GM has historically always like made some pretty bold moves.
One of the first EVs,
like,
for example.
Yeah, EV1 like a long time ago, and even in 90s, like OnStar, when it came out, it was like the first time. It was kind of mind blowing to me. Connected vehicle, and even the Chevy Bolt and Bolt, like both of them are like pretty cool things. Okay, and how can you forget like the early investment in Cruise? Back then, like it was not yet like a major fashion to do all this AI. So I think like that heritage definitely was something that was important. Two, the cars are something that like everybody can resonate with. It's like something so many of us are like interested in. It's a part of our daily life, and so many of us want to work on things that impact our lives. And there's this whole thing like around movement right in both automation as well as like electrification. So that's like a big thing. And so it ultimately comes back to the value proposition of like the work that you do and the importance of it, and how is it going to impact the world. So I mean, when I looked at all of that, it was like, wow, okay, this is a really good place. And now focusing especially on AI, like data keeps coming as a recurring theme here. Like you do need to have like a ability to capture like all the various long tail events that we talked about. And like with a company like GM that has like the number of cars that we deploy on the road, there's a big opportunity here, like to be able to take that, marry like the high tech mindset, stuff that we've learned from Cruise to put together something really, really interesting. How many places in the world can you do that?
I completely agree. It's an exciting challenge. It's what makes me excited about the whole industry. Is just the in-person component of the physical vehicles and things like that. So I want to talk a little bit about L4 autonomy and then later GM's ADAS strategy and software strategy. First on L4, you've worked in both L4 and now your focus is in ADAS. It's rare to meet people that have both experienced both. How do you think the industry looks at the technology between them? How do you think that developing one can influence the development of another?
Yeah, so it's interesting being in this space ever since like it started taking off. Like you could see the arc there, right? Like in 2015, 2016, when we just started going, I remember like telling my kids that, hey, you will not need to learn to drive. I just dropped my older one off for his freshman year in college, and he had to learn to drive. And the younger one is like a sophomore in high school. He's going to drive. So I think that we vastly underestimated the timelines that it takes to like get to L4. But that said, I don't think that it's also like science fiction.
It exists today.
It exists today.
Yeah,
like you can go to San
take a
Francisco, you can take a Waymo taxi. Before a couple of years ago, you could see like all the cruise cars like doing some pretty amazing things on the road. So there's like so much that has already happened in L4 world. So it's mostly, in my opinion, like a matter of time, and we are terrible at like predicting like these breakthroughs and when that and how
it's always too slow till it's too fast.
Exactly, and then suddenly like it just takes off. So the other thing that I will say is that like like the ADAS, the focus on L4 was actually really good for the industry because so many interesting things came out of that. Like so this whole like ability to do deep neural networks on power constrained systems in a car. That's kind of what like where like ADAS is headed to. Improvements in like sensors and stuff that can actually help safety. It's GM like zero accidents is like one of the top line goals that we have. So it's like really lots of things that like have benefited ADAS from the L4 work. And I also think the other way works too. Like the fact that you have like L2 cards which can do fairly complicated things now. And are able to experience like lots of interesting things with the best computer in the world, a human being at the wheel, can go and like inform like how to build your L4 system.
It's interesting in a lot of ways. It sort of reminds me of how when the world attempted the moon landing, there was all kinds of new technology that emerged as a byproduct of like attempting space exploration and things like that. So I think there's some of those dynamics that exist, but the main difference is the technology does exist today, but the timelines were longer. In terms of the safety, how is the focus on safety different between L4 and ADAS?
Yeah, so there's a continuum of these autonomous systems, right? Like in automotive, like we generally think about like this thing called functional safety, which is basically what happens like if something fails, like how do you handle it? And there's something called SOTIF, which is saying how well does it work when it works. So on both these axes, you kind of have different gradations, like as you go from L1 to L4. So when you're building like a L1 system, the goal there is like the human is the person I'm driving, and then my car watches over me. And it prevents me from doing like some really bad things, right? So I kind of think about it as my guardian angel in the car, right? And so in a system like that, like you really need to focus on like something like a high recalls. I'm assuming again you're familiar with like the precision and recall trade-offs that like happen in like any machine learning system. So you kind of have to push hard on the recall, so it like all is guaranteed to protect. Once you get to something like an L2 system, then different aspects of safety come in, like right, like so it's if the car is driving and the person is and then the person is monitoring it. So in that sense that it doesn't require like a backup system because the backup system is a person, but at the same time, so many things of that system itself it need to be operational in order for it to be turned on. Driver monitoring is a good example, or like maybe whether the sensor can see the road. Maybe a sun glare blocks it. Like there's a whole bunch of things that like need to be accounted for. So you need to build a fail-safe system that can deal with that. And maybe you can dial back a little bit on recall in some of those elements there because like you have a person who can deal with it and focus a little bit more on comfort. Because pushing hard on like recall can also cause like a bunch of false positives. If you go further into L3 and L4, like it's the person is not driving. So at that point, like you really have to have a redundant computer, like which can do it, which can do take over, like in case the first one doesn't deal with it. And I don't just mean a redundant computer. Everything is redundant, right? Like you need to have sensing redundancy, you need to have like power redundancy, cooling redundancy. So many things like need to happen. So yeah, so the safety bar just keeps going up, like as you go into like more and more levels of autonomy.
And then in terms of the operation of these systems, Cruise has faced some tailwinds in the deployment of robotaxi. Waymo oftentimes faces challenges related to human and environmental conditions. What are some of the things that you think need to change to enable these L4 AVs to succeed in the long term, be able to operate in more diverse environments? How do you think about that?
Is your question how do we make an L4 system operate in more diverse environments?
Yeah, what do you think are the kinds of technological changes?
It's a good one, right? Like so, okay. I think fundamentally the kind of sensors we have will continue to evolve. Like, I mean, you kind of have to have sensors that work in the night, in the dark, like in fog, in San Francisco, all kinds of things. I think like many of them are already there. I mentioned the ability to anticipate all kinds of environmental differences. Like when I go and drive in a completely new country even, it doesn't take me that long to get oriented. So we need the algorithms to be able to get to that point, like where they can handle these various differences between. So basically, we need like scalable. We need like scalable algorithms, and it's actually like happening. This whole direction with foundation models is super exciting because what these do, like I mean, like I'll give you there's this model. There are these models out there, like which you've trained it with like large scale internet scale data, and they just like learn like what the thing is, and so now it doesn't matter like when it sees something new, like there is something that it has in its like brain, if you will, that tickles it and that it knows how to deal with it. So those approaches are really, really interesting, like that can be pushed to scale things in a more broader, diverse environment to work.
On the note of sensors, Tesla has famously done a camera-only system as they kind of expand into this L2 plus domain. What do you think about the industry minimizing the sensor modalities? How do you think about this, impacting the level 4 autonomous vehicle space?
I think the sensor, it really comes down to what product you're building, right? Like, so if you are building a car that you want to make it affordable and something that will sell, clearly it can't look like those ugly watts stuck on it, like and hundreds of or maybe tens of sensors, like festooned all over the car, like that makes it like look both ugly and extremely expensive. So that's not possible. That's not going to sell very much. So I think like that's one of the reasons why you see like this trend to kind of be minimalist in your like usage of sensors. And so when you go towards like lower end of autonomy, like you do tend to kind of see like less of those, and it's less intrusive. Like you can make it affordable. But as you go, like I said, like the bar for safety becomes really high, and then you start seeing like more other sensors. And but really, like it comes down to like the three main sensors, right? Like you have LiDAR, radar, and like cameras. And cameras are just going to continue to be like more and more dominant as AI improves, because camera is directly tied with AI. And as your compute becomes cheaper, like just follows Moore's law, like those will become more and more dominant. Radar and LiDAR are there for redundancy reasons, as I said, like because if you build a system, especially like in higher levels of autonomy, which has exactly the same set of sensors and same kind of like algorithms, it'll make the same mistakes. So it's not really redundant. So you do want to have like some mix of things there to enable like the greater levels of autonomy possible. So I don't think it's like it's a trend. It's like really got to do with what product that you're building. So for example, the GM, like we have an L2 system that we sell today. Actually, we've been selling it since 2017. It's called Super Cruise. And Super Cruise, all it needs is one camera and one radar. You can make it like super affordable and put it in many cars.
That's a great segue into GM and your approach to ADAS. Our companies work very closely together all over the world. Tell us a little bit more about your focus areas at GM, and then just the overall approach to ADAS.
Yeah, I mentioned we have. So I'm responsible for ADAS, and ADAS is like active safety and advanced driving. So active safety is like what we call L1, automatic emergency braking. And then there's also like a bunch of things we call low velocity maneuvers, like parking is a good example of that. So there's a set of things that like we do for that area. And then there is like the L2 work and beyond that we focus on. So yeah, my area of focus is all of that. And as we go march towards higher and higher levels of autonomy, we do need to be embracing more of these latest and greatest breakthroughs in AI. And so a lot of my focus is to see how we can bring those kind of approaches to improve the performance of our cars.
What does that look like in terms of the technology improvement? What are the kinds of challenges that you're looking to overcome? With this investment, there's the GM Silicon Valley Center, things like that. What is sort of the
so the three main ingredients I would say in building any complex AI system, you need data. I mean, always data comes in. You need compute, and then you need people who know how to use it. So we talked a lot about data. We have to figure out how do you not only collect the vast amounts of data, but filter it out, because it can get expensive very, very rapidly. And you can see that by the amount of investment that is going into the various AI companies. So you have to figure out how to not just do AI, but don't do it blindly, but figure out how to do it affordably. Similarly, on the compute side, when you push hard on those foundation models, it can be very, very expensive. The size of the clusters that you need to build becomes very, very big. And even in the car, those algorithms need to translate and be able to run in a very, very power-constrained environment. I mean, it's not as power-constrained as your phone, but still, you don't want to use up more compute, the power for compute, than driving, because that's really the reason why the battery exists in the first place. So there's a lot of focus on that. And then on the people front, the reason why we set up this place here in Silicon Valley, it's just right across the bridge from here. It's really cool. I should have walked in this morning. There was way too much traffic. But
who needs autonomous cars when you can just walk?
Yeah, exactly. In some cases, I feel don't try to solve tech using high tech. Low tech works. So yeah, I would have just walked had I realized that there was so much traffic. But yes, and it's a great location because there's an amazing amount of talent in this area. Silicon Valley is always the best and brightest in the technology world are here. So you are able to reach out and attract the best.
Maybe just last question here quickly. What's your take on the market in China? We visit China often to understand the latest in technology there. Given the pace of advanced technology in China, how do you think about how other automakers will have to keep?
Yeah, so we also sell cars in China, and in China, we have taken a different approach for all the various governance and reasons there. So we work with a company called Momenta, which we've invested in. So they build our system there for that market. So we are pretty well aware of what's going on. But my attitude towards that is, it's very impressive to see the advances that are happening there. But at the same time, I feel what is really important is focusing on building what the customers need. It's, I mean, there's some pretty impressive things happening in the US too, in the world of AI. But so it's, what we really need to do is, and what I'm focused on is building what our customers need. A good example of that is what we did with Super Cruise trailering. I mean, as you all know, right, like US is a huge market for trucks. We build and sell like these amazing trucks. And people haul their toys on the weekends or for vacations. And getting that like to work with high winds and like, pulling a heavy load and figuring it all out is kind of tricky. And so we extended Super Cruise to work with trailering. And that's like an example of the kind of things that we look at that might not be very interesting in China. So, but that's something that is really, really applicable in the US. So you kind of have to like figure out like what the market is and focus on it. So that's kind of what I tend to focus on. And like I said, it's very, very impressive to see generally the explosion of this technology everywhere.
Makes sense. Thank you so much for the time today, Anantha. This is a fascinating conversation on things in AI and ADAS and beyond. So thank you.
I'm happy to be here, and thank you for the partnership.